This video introduces DEICON's semi-active tune mass damper and demonstrates its tuning adaptability. DEICON's semi-active TMD can adjust its tuning frequency as well as its damping level in real time with no change in its hardware. These attributes enable the semi-active TMD to adapt itself to any structural change as well as any variation in usage pattern and loading conditions of its target structure. The semi-active TMD can be configured to abate vertical vibration, such as walking-induced floor vibration, and to abate horizontal vibration, such as wind-induced lateral vibration of control towers and pedestrian bridges. Air springs make up the suspension elements of the semi-active TMD, realizing the static stiffness and thus the nominal tuning frequency of the TMD. DEICON's proprietary control technology regulates the flow of compressed air in and out of the air springs, adjusting their stiffness and damping, and thus fine-tuning the TMD via software in real time and in situ. In a number of demonstrations, one configuration of DEICON's semi-active TMD, that is inverted pendulum, is used to exhibit the ability of the TMD to adjust its damping and stiffness in real time. In the first demo, the TMD is forced to resonate, with damping control turned off. Upon reaching steady-state resonant vibration, the forcing is turned off, and simultaneously the damping control is turned on, causing the TMD to stop in a few cycles of decaying oscillation. In this demo, a rather small amount of damping is programmed into the air springs, bringing the TMD to rest in a graceful fashion. The demo is repeated, resonating the TMD again with the damping turned off. Upon reaching steady-state resonant vibration, the forcing is turned off and simultaneously the damping is turned on. Except this time a sizable amount of damping was programmed into the air springs, causing the TMD to stop in only one cycle of oscillation. Clear from these demonstrations, DEICON's control strategy can introduce various levels of damping into the TMD. The required level of damping depends on the application. The semi-active control system is capable of realizing whatever damping level is desired. Stiffness adjustability of DEICON's semi-active TMD is demonstrated by changing its tuning frequency by a factor of 2. As mentioned earlier, DEICON's control technology adjusts the stiffness and damping of the air springs, fine-tuning the semi-active TMD in real time and in situ via software. In a number of additional runs, the capacity of DEICON's semi-active TMD in adjusting its tuning frequency as well as its damping is demonstrated by measuring its frequency response functions with the device tuned to 4 different frequencies and 3 different damping levels. As shown in these frequency response functions, the tuning of DEICON's semi-active TMD can be adjusted over a wide frequency range with various levels of damping, making it ideal for a variety of tuned damping applications requiring occasional retuning. In yet another demo, the semi-active TMD is tuned to 5.9 Hz and it's the transient response with the damping control off and then on is measured. With the damping off, the decaying oscillation lingers for a long time, and with the damping on, the oscillation stops quickly. All in all, DEICON's control technology enables the semi-active TMD to be readily tuned, retuned, and stay optimally tuned and thus remain most effective in adding tuned damping to its target structure.